Now, this is back to the textbook block diagram. Now they're showing a block diagram of a typical embedded system. The microcontroller is in the center, and it has these built-in I/O features, including ADC, digital I/O, serial port UART, CPU, core, ROM, RAM, SPI, I2C, counter, timers, bus interface, and so forth. And then everything else is just attached. So if you have sensors, then that comes in a lot of times over the ADC, because that usually gives you a voltage, and then you convert the voltage to a number. That's what ADC does. Or if you have to drive a speaker or drive a motor, you could use DAC, but oftentimes you actually use what's called PWM, and we'll cover this later. So basically, it's a 0 and 1, but then you switch between 0 and 1 very quickly. It just depends on the ratio between on time and off time. So a lot of the motor controls actually is done with PWM. Communication with the host computer, usually over serial port. Non-volatile memory could be done over its bus interface or over SPI. Just depends on how it's mapped also, right? So there's different architecture, and we'll actually spend time on different components, different interfaces, so that you actually get a firm understanding of how each one works. Now, so what I want to do actually is to go up to a higher level, because most of the time when you're designing an embedded system, you're not just working with a chip. You do have to understand the chip, but there's a lot of support structure around the chip, and that's what a platform is. A platform is usually what our starting point for embedded systems. A platform is a reusable system design that has close to the features that you need. Maybe it's missing one or two. Maybe it needs to be customized a little bit, but at least you get to work on the key issues, so you get something working quickly. And then the next time around, you can customize the board by adding the necessary features and then satisfy all your constraints. So that's what's called platform-based design. Now, a platform is more than just hardware, even though that's what most people see. So our EcoBT board here is a platform. We've used it for at least 10 or more applications to date. And I think you'll get to use this for more applications as well. Now, but it's more than just hardware boards. It's also software, library, maybe operating system, maybe drivers, and a lot of application code as well. Now, so the microcontroller platforms we use, well, there could be virtual platforms as well. So EdSim51, which I showed in the first lecture, that's also a platform, but that's a virtual one. There are boards in reality that actually correspond to the real one, and it's actually a very realistic one. It's timing accurate, cycle accurate, and so if you get the code working in the simulator, chances are it'll work almost the first time you port it to the real board. Now, there are many other boards available on the market, so what I want to do is to really show some of these examples and show the kind of variety that you can see. Of course, we'll use our EcoBT, but then only after we've taken a look at some of these other boards. Now, if you want to buy some boards out there, one starting point might be to just type in evaluation boards in your search engine, and you'll come up with boards that have the microcontroller and maybe some peripherals on there. And what are these peripherals for? Well, they support a lot of things that you might not want to deal with directly, but they are necessary. For example, maybe it needs a regulator, a voltage regulator. That is, you might say, oh, I just want to have it. Well, it needs power, but what kind of voltage, right? Does it work? And so, regulator is one that's important. It gives you steady voltage, so your system will run properly. You might also want the ability to connect different kinds of devices. So you need a prototyping area that is reserved just so for quick prototyping. You might want a few buttons that just so that you can have some input or reset or some basic selection, some basic way to input to the system. It'd be useful to have LCD or LED just so that you know what's going on. Otherwise, it has no way to tell you what's going on. It's just running code. And so evaluation boards are convenient and ready to use. But as part of the evaluation board, you need to also consider whether or not it's supported by what kind of programming tool or debugging tool or simulator. You should have at least an assembler. Now, compiler is pretty standard nowadays, but used to be assemblers. You need tools to be able to do useful work. Otherwise, it's very hard to code in assembly. Now, let me show you some example. This one, I think, is at least almost 10 years old, but still pretty good, I think. And you can still buy this board. This is the AVRButterfly. Sorry, the Y gets cut off. But it's $20 US. It has an 8-bit microcontroller by Atmel, and then has an LCD. It could actually display text, letters and numbers and symbols on that. And it has temperature and light sensors, a tone generator, and in fact, it has a 512K flash over SPI, but that's not program flash, I don't think. That's just a data flash. And it comes with a bootloader, or you can program one in, so you could actually program it over serial port. And this microcontroller actually has rich I/O capabilities. UART is a universal asynchronous receiver transmitter, or serial port, more commonly known. And we'll spend time talking about how UARTs work later. SPI is another common one, serial peripheral interface. USI is some combination between UART and SPI. You can choose. PWM, that's for pulse width modulation. That's basically to use pulses to control motors or light intensity. ADC, as you may have heard, timer, counter, built-in LCD driver, and general purpose I/O. So, yeah, you can still get this one. And moreover, it has a little safety pin on the back of this. So you can put it as a name tag. And hello, my name is... and that black dot there on the right, under Atmel, that's a joystick. You can do up, down, left, right, and then select center, right? So pretty nifty little system. And so I think this one definitely is worth a look. And the circles, rows of circles, really, those are your prototyping area. So you can solder pins on there. And so, yeah, you can build interesting systems with this one. And it runs on a coin cell battery, 3 volts. Okay, and so now this is the kind of the system block diagram for the AVRButterfly. So the microcontroller is that ATmega169, and it has the hardware connection with the resistors, and then the JTAG can be used for programming and debugging. There's a speaker tied to the PWM output, so we can make square tones. You can even play some kind of music tones with it. Okay, and then data flash. So it has quite a few of these really interesting controllers all in one. Of course, most of the pins are used for the LCD driver because that just takes so much. I think it takes 30 or 40 some pins out of the 55 or 50 some pins. But still, you don't have to use all the pins of the LCD if you don't want to. And there are ways to kind of disconnect and reallocate those pins. It's all software controllable.